Hi guys, welcome to the Linux channel. From past couple of days, I'm almost having sleepless nights because I'm working on a new fork TOFFEE project meant for data center applications as well as in server systems and load sharing platforms, and as well as cluster based cloud computing systems and so on. The existing TOFFEE, in case if you take you can use it for Internet of Things devices, you can use it for satellite based communication, and you can use it for space based communication links and so on. Whereas when it comes to huge data center applications, this is where the existing TOFFEE, since it is been developed inside the Linux kernel core, it is going to have significant amount of scale up issues. At the same time, if you are choosing a very small hardware, you are going to also have issues like scale down issues. So this is the kind of inflexibility you get if it is completely within the Linux kernel core. Whereas the new TOFFEE, the data center version, is going to be split across so that you have the TOFFEE's kernel based modules, which is going to do some amount of packet processing, as well as it does basic validation, and then it passes down to the TOFFEE user space components, which it is currently being developed. So the idea is you can split the task with multiple processors, so that these multiple processors or multiple threads, what is going to happen is they are going to do packet processing in much orderly fashion, as well as it is going to scale up in case if you have a Xeon based multi-core and multi-CPU based servers. It is going to split across into multiple computing units, and these modules are going to process simultaneously throughout various packets it gets, and then it is going to pump these processed or optimized packets out to the network as well. So this is the kind of difference you get the TOFFEE which is existing before versus the TOFFEE, the new TOFFEE data center based version. So I was doing the prototyping. I have done a basic prototype, the C based implementation, so that it can be tested across with multiple systems. So far I have tested in my mini PC, I have tested with my Core i7 Intel system, and then I have also tested with one of my clients Xeon system as well. So I found it is extremely versatile and extremely good in terms of scaling up with respect to your hardwares. Whereas the existing TOFFEE, what happens is in case if you deploy it on a Xeon server, it is still dependent on per core performance, and you may find not much of CPU being consumed, or else the CPU load, it may not show significant CPU load, whereas still it may have some sort of degraded packet processing performance as so. Whereas with respect to the new TOFFEE, which is meant for data center based applications, this is going to be completely different. It's not that well suited for small devices, because if you have a very small device like an ARM based network processing or network processor based devices, or else some sort of MIPS based hardware appliances, these scenarios, it is good to choose the existing TOFFEE, which is still going to have the development being done, and it is going to continue as a separate individual entity as such. Whereas in a case like TOFFEE data center, what is that I'm going to plan is it is going to have sequential features being added time to time, and it may also have some new features which may not be yet supported, or else not feasible in terms of supported in the existing current TOFFEE. So this is the difference it is going to be. So apart from that, the TOFFEE data center version, it is going to be very interesting, so that in case if you have some kind of load balancer systems in place, you can split your existing traffic in multiple channels, and then you can feed them across to various servers of TOFFEE data center, not just one device installed with TOFFEE data center. You can have multiple systems, and then you can share the load. In case if you are having like 10 Gbps or 50 Gbps links, so such kind of high speed links, or else it can be sort of multi-line network links. So in that case, you can have this load balancers, and in that case the load balancers are going to do splitting your traffic, and with respect to whatever channels it has splitted your traffic, you can feed it to the existing TOFFEE data center device, and then these devices can be incorporated in Xeon based servers, and with respect to multi-core architecture of the servers, it is going to take the advantage of the same, unlike the earlier TOFFEE, because the earlier TOFFEE, since being in kernel space, it is extremely dependent on any specific CPU core it latches on, so that in case if the packet processing gets delayed, it has to process these packets in sequential order, whereas in a case like the new upcoming TOFFEE data center version, this is an issue it is not going to face, because I have designed the architecture in a way that it can handle asynchronous packet processing, and it can cope up with any sort of loads, and there is not going to be a single point of failure, unlike the earlier TOFFEE, because earlier TOFFEE, since it does everything in the kernel space, sometimes the kernel itself may crash, and sometimes there may be a bugs within the TOFFEE. So there can be various reasons, and in these reasons, for these reasons, the existing TOFFEE cannot be used in some of the carrier grade applications, whereas the data center version, it is going to be completely different, and it may have like 4 to 50 threads, and each thread may do the same job essentially, and few threads will do packet processing in one direction, the other set of threads are going to do packet processing in another direction, so that in one direction it will compress these packets, in other direction it is going to decompress these packets. So in this way, what happens is it is going to do all these modules are going to do same or similar work, and in case if there is some kind of event or some sort of an issue, and some of these modules crashes, or else if there is some sort of an issue with any of these modules, the other modules are going to take over the job, and it is going to handle the system efficiently, unlike the earlier version. And this way, what happens is there is not going to be a single point of failure, and if you have very good server hardware with RPS power supply, as well as and redundant RAID based server based chassis, you can have your system uptime guaranteed. So this is the effort being put towards, and this really needs a complete new architecture, and this is what I was extremely busy from past many days. So I hope you liked watching this video, guys. In case if you have any questions, please post it in YouTube comments, or else you can send me an email across. Thank you once again for watching this video. Have a nice day. Bye bye.